Hey there, class. Mr. Prosky here. Hope you're having a good day so far. We're continuing with Chapter 6 today, brand new chapter. This chapter is called about linear inequalities. So linear equations was like y equals 2x minus 7. A linear inequality is going to be something like y is less than 2x minus 7, something like that. Or you could do it in standard form like 3x minus 5y is greater than or equal to 9, something like that. These are all linear inequalities. Basically, they're going to be less than, greater than, less than or equal to, greater than or equal to, and stuff like that. So, so it's going to be some similarities to solving equations and stuff with equations and graphing equations, and there's also going to be some slight differences as well. So let's get right into it. Today is 6.1, and the name of the lesson is Solving One-Step Linear Inequalities. Our essential question is, how do we graph and solve linear inequalities? So we have a warm-up. It says, which of the following numbers are solutions to this inequality? X is greater than 5. All right. Well, let's do the first one together. Let's do the first one together and see if we can figure out the rest on our own, okay? So x equals 9. Well, I'm literally going to take 9. I'm literally going to take 9. I'm going to plug it in for x and see if it's true or not, right? So let's do that. Let's do 9. What symbol is this right here in the middle here? Hopefully you said greater than. There was this stuff from middle school where we talk about like the alligator eats, it's got teeth in here, and it eats the bigger number. That's not always the case. This, if it's written like this, is always greater than. Okay, when we get to like algebra 1 and stuff, it's always greater than. It doesn't matter if the numbers don't match up or anything. It's always going to be greater than, which means this is always going to be less than. Okay, so just be the way I like to treat that. If you make an L with your fingers, that's your like pointer and your thumb, and you turn it sideways, that's going to be that's less than. That's how I kind of remember that L is less than. So take your left hand, make an L, turn it slightly sideways. That's going to be less than. Okay, to help you remember which one is which. Okay, so is 9, this is greater than, is 9 greater than 5 or no? It is. So do you think it's going to be a solution or not if it's true? It's going to be a solution if it's true, okay? Why don't you guys try B and C on your own and see how you do? All right, welcome back. We have x equals 2. Let's check that. 2 is greater than 5. Is 2 greater than 5 or no? It is not. So this is going to be not a solution. All right, what about C? X equals 5. So this one's going to be 5 is greater than 5. Well, is 5 greater than 5? You may have been tempted to say it is a solution, but 5 is not greater than 5. 5 is equal to 5. If it had this line underneath it, which means equal to, that would be true, but 5 is not greater than 5, so this is going to be not a solution. Okay, it needs to be exactly true. One or the other. It can't be like 5 is not bigger than 5, so it's literally not a solution. Okay? All right, let's get into graphing linear inequalities here. So we have the inequality x is greater than 1. X is greater than 1. Well, this verbal phrase is literally going to be all numbers that are greater than 1. Okay? So, what numbers are greater than 1? Well, here's 1. I'm just going to put an open circle like this here for now. You'll see why in a second. We'll come back to that. I'm going to put an open circle on 1. Which numbers are greater than 1? To the right or to the left? To the right. Just like on a number line, the numbers get bigger to the right. If we're looking for numbers that are greater than 1, we're going to shade to the right because those numbers are going to be greater than 1. 2 is greater than 1. 4 is greater than 1. Whereas if we check negative 2, negative 2 is not greater than 1, so it's not part of the solution. This shading that we're doing, we could shade like this too if you wanted to. Another way that people do is they go like this. Shading means that it's part of the solution. Okay? And we'll come back to the circles in a second here. I'll come back to that in a second. But we'll use an open circle for this one. Okay? What about x is less than negative 3? We have all real numbers less than negative 3. Okay. Well, I'm going to put an open circle on negative 3. Now, which numbers are less than negative 3? To the left of negative 3 or to the right of negative 3? Well, less than is going to go to the left, so we're going to go like this. So, a couple ways to remember which way to shade. I don't like my arrows. A couple ways to remember how to shade. The arrow, literally, if X is on the left-hand side, the variable's on the left-hand side, it literally points which direction you're going to go. The inequality symbol is going to point which direction you're going to go. Another way you could check is you can test numbers. So you can say, well, I'll test 3. Is 3 greater than 1? That's a solution, so you're going to shade towards 3. You're going to shade towards 3. There's one other thing that I usually tell people. I'm trying to remember what it was. It'll come back to me. I'll remember it during class probably. But yeah, the arrow literally points. As long as the variable's on the left-hand side, the X or the A or the B or whatever, it's always going to point which direction you're going to shade. And you can also test which numbers are going to work. Or you can just figure out, you can literally just think of it. This is the third thing. Just literally think, what numbers are greater than 1? Well, numbers that are greater than 1 are literally all of these. These are all greater than 1, so that's the direction I'm going to shade. I'm not going to shade this direction because those are not greater than 1. Okay? Those are the 3 ways to do it. All right, next one. We have X is greater than or equal to 2. This one is greater than or equal to 2. Okay? I'm going to use a closed circle on 2 now. I'm going to use a closed circle on 2. All right, what numbers are greater than or equal to 2? Well, the arrow's pointing to the right, so we're going to shade to the right, but let's just double check that. Is 4 greater than or equal to 2? It is, so we're going to shade toward the true side, which is going to be that direction right there. Or you could also test numbers too. All right, last one we have is X is less than or equal to 0. All real numbers that are less than or equal to 0. So I'm going to use a closed circle on 0. And we're going to shade, if it's pointing to the left, numbers to the left that are less than 0 are to the left, so we're going to shade to the left. Or the third option is to test a number. We could test 5. Is 5 less than or equal to 0? It is not. So we're not going to shade towards 5. We're going to shade away from 5. We're going to shade toward the true side. Okay, now let's come back to why we use open or closed circles here. We use an open circle for less than and greater than because that value is not part of the solution. It is not part of the solution. So remember what I said before. When we're doing this shading, the shading means all these numbers that are shaded, all the numbers between the numbers, between the integers, like negative 1.5, all those numbers are numbers that are less than or equal to 0, for example. So shading means they're part of the solution. An open circle means we do not include that number in the solution. So, for example, is 1 greater than 1 or no? It is not. 1 is not greater than 1, so that's why we have an open circle here, because 1 is not part of the solution. The open circle means there's like a hole there. It means don't include 1. Whereas these ones down here, these ones are part of the solution. 2 is greater than or equal to. It is equal to 2, so we can include that in the solution. So that's what the open or closed circles mean. So down here, we use a closed circle for less than or equal to and greater than or equal to because that value is part of the solution. Okay? So equal to, closed circle, less than or greater than, open circle. All right? But just remember, equal to is a closed circle because it's part of the solution. The open circle means don't include it. All right, there's some examples you can try down here. Don't worry about the different variables, x, z, w. They're all the same. Doesn't matter. But go ahead and see if you can graph these, and we'll check your answers in a second. All right, x is greater than negative 2. It's going to be an open circle on negative 2 because negative 2 is not equal to. And we're going to shade to the right. It's numbers that are greater than negative 2 or numbers to the right are greater than negative 2. Z is less than 4, open or closed circle. It's going to be an open circle because it's less than, it's not equal to. It's going to be numbers shaded to the left. It's pointing to the left, we're going to shade to the left. Number 3, W is less than or equal to 1, open or closed circle. It's going to be a closed circle, and we're going to shade which direction? To the left, because it's less than or equal to 1. These numbers are less than or equal to 1. These ones are not, so we're going to shade toward the true side. All right, good job. Let's keep moving along here. Got my packet in front of me. All right, solving a linear equality. So remember solving equations? So if we had 3x plus 5 equals 18. You subtract 5 from here, you got to subtract 5 from here. You divide by 3 here, you got to divide by 3 over here. Remember all that kind of stuff from chapter 3? Okay, you can go back to that chapter if you need a review, but we're going to use the same steps for solving a linear inequality as we do as we were solving a linear equation. Okay, so as a reminder, let's write that down for a sec. We have to use what are called inverse operations. Inverse operations. So opposite of addition is subtraction. Opposite of multiplication is division. Okay, so you do inverse operations. And one more thing to be careful about is that you want to keep the variable on the left. So, for example, it says you may need to flip it. So we have -6 is less than x. We want to put the variable on the left and put x as on the left. So it's going to be x is greater than -6. So you see how it was pointing to the -6. When we flip it around, it still needs to point at the -6. And same thing over here is pointing at the pointing at the t. It still needs to point at the t when we flip it around. Okay. So I sometimes try to let people keep their variables on the right-hand side, but usually that goofs them up. So I would just encourage you, because it becomes a different thing. If you have, for example, if you had -2 is less than x, it is saying that -2 is less than all the other numbers. So basically, this is still the same solution, but it's basically saying that x is a number that's x is still a number that's greater than -2, or -2 is less than all the numbers that are x. So all these numbers here are -2 is less than all these numbers is kind of what it's saying. So I would just kind of avoid that confusion. It's going to be confusing if you do that, and just make sure the variable's on the left-hand side. All right, let's get into it here. So if x plus 6 is less than 9, if we had x plus 6 is equal to 9, what would be our first step to solve this? Hopefully you said we're going to subtract 6 from both sides, which is what we're going to do. Same thing. These are going to cancel. X is less than. Keep the sign the same for now. What's 9 minus 6? It is 3. Ta-da! Congratulations. You just solved a linear inequation. Linear inequality. Sorry, linear inequality. My bad. It's an inequality. So if we graph this, is it an open or a closed dot if it's less than? It's an open dot because of less than. And x is less than 3. We're going to put an open circle on 3, shade to the left. Okay, so it's pointing to the left. Numbers to the less than 3 are to the left. All right, number 2. We have -12 is greater than or equal to m minus 10. So if it was -12 is equal to this, how would you solve it? Well, you're going to add 10 to both sides, right? These are going to cancel. We're going to get -2 is greater than or equal to m. But we don't like this. We're going to flip it around because we want the variable on the left. But when we do that, it's pointing at the m, so we need to make sure it's still pointing at the m. So it's going to be m is less than or equal to -2. And there's your answer. Open or closed dot if it's equal to. It's closed because it is less than or equal to. And what I'm going to write over here actually is we're going to flip. Keep sign. Same way. So less than or equal to -2, we're going to put a closed dot on -2. Shaded which direction? Shaded to the left. Numbers that are less than -2 are to the left. It's pointing to the left. And you can test the number. 0 is not less than or equal to -2, so we're not going to shade this direction. We're going to shade the opposite direction. All right, a couple more examples here. We have number 3, 5n is greater than or equal to 15. So if it was 5n equals 15, what would you do first? You would divide by 5. That is correct. So n is greater than or equal to, 15 divided by 5 is going to be 3. Open or closed dot if it's equal to. So closed dot, greater than or equal to. Closed dot and 3, shaded to the right. This is our answer. I should box my answer. All right, next part is really important. This is the only really big difference between solving linear inequalities and solving linear equations, okay? When you divide or multiply both sides, we'll put, not x, we'll put multiply. Divide or multiply by a negative number, you must flip the inequality sign. Okay? So, we have negative 3x is less than 6. If we had negative 3x is equal to 6, what will we do first? We're going to divide by negative 3. But we got to be careful. When we divide by negative 3, we got to flip the less than becomes greater than, and we have 6 divided by negative 3 is going to be negative 2. Okay, only when you multiply or divide by a negative number do you need to do that. Otherwise, they're going to stay the same. Like over here, these stayed the same, right? Because we didn't divide by a negative. This one we divide by a negative, so less than became greater than. All right, open or close dot. It's open because it's just greater than. So an open circle on negative 2. Shade to the right. All right. And last example for the day, we have when you multiply both sides by a negative, you must flip the inequality sign. I just put it over there with the other one. You multiply or divide by a negative, you need to flip the inequality sign. So we have, if we had negative x over 5 is equal to negative 1, how would we solve that? Well, we got a negative there, and we have a dividing by 5. So the way to fix this is to multiply by negative 5 to take care of the negative and the 5 at the same time. So this is going to cancel. So we're going to have x is, we multiply by a negative, so greater than or equal to becomes less than or equal to. And negative 1 times negative 5 is positive 5. All right. Is it an open or a closed dot if it's equal to? Closed dot, because it's less than or equal to. And it's going to be a closed dot on 5. And we're looking at numbers that are shaded to the left. And that is our final problem for today. Thank you for watching. Have a great day, and we will talk soon.